This is my take from podcast. If you want to listen summary of podcast, start with a free trial for detailed summaries on Apple Podcasts and Spotify using link in descriptions and support with tips on Patreon. Here is key point discussed in podcast Andrej Karpathy. AGI is still a decade away. So let's dive into the conversation with Andrej Karpathy, where we explored the concept of agents and their development in the field of AI. One of the key points that stood out to me was Andrej's assertion that we're not yet at the point where we can have a truly autonomous agent, akin to an employee or intern, that can work alongside humans seamlessly. He believes it'll take around a decade to overcome the current limitations, such as the lack of continual learning, multimodality, and cognitive abilities. He emphasized that while the problems are tractable, they're still difficult to overcome, and his intuition, honed from years of working in the industry and research, led him to conclude that a decade is a more realistic time frame. Another fascinating aspect of our conversation was the discussion around the analogy between evolution and pre-training. Andrej cautioned against drawing direct parallels between the two, highlighting that evolution is a fundamentally different process that's not replicable in the same way. Instead, he views pre-training as a crappy evolution that allows us to build useful entities, albeit in a more limited capacity. We also delved into the topic of in-context learning, which seems to be a crucial aspect of these models' intelligence. Andrej suggested that in-context learning might be doing some form of gradient descent internally, although the exact mechanisms are still not fully understood. This led to an interesting discussion about the differences between pre-training and in-context learning, with Andrej agreeing that the latter feels more like real intelligence due to its ability to assimilate information more efficiently. He drew an analogy between the transformer neural network and cortical tissue, suggesting that we've made progress in certain areas, but there's still much to be discovered. We touched on the topic of continual learning and whether it's plausible that this capability will emerge spontaneously with the right incentives. While it's difficult to predict the likelihood of spontaneous emergence, Andrej's reservations serve as a reminder that there's still much work to be done in this area. So, let's dive into the fascinating world of artificial intelligence and its limitations. Imagine you're trying to build a complex system like NanoCat, a chatbot that requires a deep understanding of its underlying architecture. Now, you might think that AI-powered coding tools would be a huge help, but surprisingly, they're not as effective as you'd expect. The reason is that these tools are great at handling boilerplate code or tasks that have been done many times before, but when it comes to unique, intellectually intense code, they struggle. Think of it like this: when you're building something from scratch, you're forced to confront what you don't understand, and that's where the real learning happens. It's not just about writing code, it's about understanding the underlying concepts and how they fit together. This brings us to the concept of reinforcement learning and how it differs from human problem solving. However, this process is incredibly noisy and assumes that every step leading to a correct solution was the right thing to do, which isn't always the case. Humans, on the other hand, engage in a more deliberate review process, identifying what worked and what didn't, and adjusting accordingly. So let's dive into the challenges of making models more capable through process-based supervision. The issue here is assigning partial credit in an automatable way. It's not as simple as just implementing a reward system, because those systems can be gamed by the models. In fact, using large language models (LMS) to assign rewards can lead to adversarial examples, where the model finds ways to cheat the system. Think of it like this: if you're training a model to solve math problems, and you use an LM to judge its progress, the model might start producing nonsensical answers that the LLM mistakenly thinks are perfect. This is because LMS are giant models with billions of parameters, and they can be exploited by the training process. To overcome this, labs are trying to make LMS better judges, possibly through approaches like GANs, which involve training models to be more robust. However, this is a tricky problem, and it's not clear if it's even possible to fully solve. Another interesting aspect is the idea of model collapse, where models become too specialized and lose their ability to generalize. This is similar to how humans can become too focused on a particular topic and lose sight of the bigger picture. One potential solution is to encourage models to maintain more entropy or diversity in their outputs. However, this is a difficult problem, and it's not clear if it's even desirable in all cases. When it comes to the size of the cognitive core, the essential part of the model that enables intelligent behavior, it's difficult to predict. Some people think it could be as small as tens of millions of parameters, while others believe it will remain in the billions. The key challenge is that the training data is often of poor quality, which requires larger models to compress and make sense of it. However, if we could refine the pre-training set to focus on the cognitive components, we might be able to get away with smaller models. In terms of charting progress towards full AGI, it's challenging to define a relevant y-axis. Some people propose using education levels or horizon lengths, but these metrics are imperfect. A more useful approach might be to focus on the model's ability to perform economically valuable tasks at human performance or better. The conversation highlights that even with advancements in AI, some jobs, like radiologists, are still thriving despite predictions they'd be automated out of existence. This could lead to new interfaces in companies that manage these eye-human collaborations, especially in jobs with more repetitive tasks, like call center work. Another interesting point is the difference between automation and superintelligence. This perspective suggests that the impact of AI, even in its most advanced forms, will be more of a gradual progression rather than a sudden exponential leap. The idea of a gradual progression is further supported by looking at historical growth patterns. Despite significant technological advancements, the rate of growth has remained relatively constant over the past few centuries. This could potentially lead to a significant increase in growth rate, similar to the jump seen during the Industrial Revolution. The debate centers around whether this represents a discrete jump or a continuation of the gradual automation and improvement we've seen historically. Ultimately, the discussion leaves us with more questions than answers, highlighting the complexity of predicting the future impact of AI. So, let's dive into the fascinating world of growth, intelligence, and AI. It's intriguing to consider how growth is driven by people coming up with ideas and executing them, leading to valuable output. However, the stagnation of growth in recent years, coupled with stagnant population growth in frontier countries, raises questions about the future of exponential growth. The conversation then shifts to the remarkable advancements in AI, particularly with Google's VA 3.0. The improvements in coherence and audio quality are notable, and it's exciting to see how fast these models are improving. The update makes VO even more useful for animating ideas and explainers, and its accessibility through various platforms is a significant plus. Now let's explore the concept of intelligence and its evolution. It's surprising that intelligence evolved at all, considering it's a relatively recent development. The idea that the evolution of intelligence might be a rare event is thought-provoking, especially when considering the vast number of planets that could potentially support life. The discussion around the scalable algorithm that humans and primates possess, which allows for marginal increases in intelligence, is also insightful. The notion that humans found an evolutionary niche that rewarded intelligence, whereas other species like birds and dolphins may not have, adds another layer to this complex topic. The conversation then delves into the world of large language models, LLMs, and their potential for creating culture. The idea of an LM scratchpad where it can edit and learn from its interactions is an intriguing concept. The possibility of LMS writing books for other LMs or engaging in self-play to drive intelligence is also explored. However, the current bottleneck in achieving this level of collaboration is the fact that LMS still resemble elementary school students in terms of their cognitive abilities. While self-driving cars have made significant progress, the journey from demo to product is long and arduous, especially when considering the high cost of failure. However, the latency requirements and model size implications for knowledge work at scale are still significant considerations. While there are historical precedents for overbuilding in other industries, the overall sentiment is one of optimism, with the belief that the rapid progress in technology will ultimately lead to successful deployment and utilization of AI. So, let's dive into the fascinating world of education and AIQ. The conversation revolves around building the ultimate learning experience, which the founder of Eureka envisions as the Starfleet Academy for Technical Knowledge. The goal is to create an elite institution that's always up to date, premier, and caters to the unique needs of each student. They want to build an actual tutor experience, not just a KOA session with a language model. Think about it like this: when you're learning a new language, a good tutor understands your strengths, weaknesses, and learning style. They serve you the perfect information, always challenging you just the right amount. That's what Eureka aims to replicate, but with a twist. The founder wants to make learning so effortless, so enjoyable, that people will do it for fun, just like going to the gym. The vision is to create a world where anyone can learn anything, trivially, and people will do it because it's desirable. Now you might wonder, how does this relate to keeping humanity in control of AI? Well, the founder believes that empowering humans through education is crucial. They envision a future where people can go much further in their learning, knowing multiple languages, or mastering various subjects. It's not just about entertainment, it's about enabling humans to influence the future, even if it's just for a transitional period. The founder also shares some valuable insights on teaching. They emphasize the importance of finding the first-order terms, the essential components of a system, and simplifying complex concepts. This approach makes learning more motivated and enjoyable. For instance, their tutorial on transformers starts with a simple lookup table, gradually building up to more complex concepts. This method helps learners understand why each piece is necessary, making the learning experience more engaging. The founder believes that, for now, it's about collaboration between humans and AI. The key takeaway is that education is a technical problem to solve, and with the right approach, learning can become trivial, desirable, and fun. So, when it comes to learning and explaining complex ideas, there's this really interesting dynamic at play. This is what's known as the curse of knowledge, where you take certain things for granted and can't quite put yourself in the shoes of someone who's just starting out. One way to overcome this is to actually try to explain the concept to someone else. This forces you to fill in the gaps in your own understanding and make sure you truly grasp what you're talking about. I found that explaining things to others is a beautiful way to learn something more deeply. It's almost like a form of selfless education, where the act of teaching someone else helps you solidify your own knowledge. Another strategy that's worked for me is to alternate between learning depth-wise and breadth-wise. So on one hand, you're diving deep into a specific topic to achieve a particular project or goal, and on the other hand, you're also exploring a wide range of subjects to get a broader understanding of the field. This approach has been really helpful for me, especially when I'm trying to learn something new in a field where I'm not an expert. It's like they're compelled to just say the thing, without all the jargon and abstract language. I have seen this happen many times, especially in academic settings, where someone will summarize their entire paper in just a few sentences over a casual conversation. It's amazing how much more clarity you can get from just having a simple human conversation.